Good morning and welcome back to Math 098 Elementary Algebra. We are going to continue with our understanding of factoring trinomials. So a couple classes ago we started learning how to use AC grouping for trinomials whose leading coefficient is greater than 1. And then we said, okay, well, what happens if you have a trinomial whose leading coefficient is equal to 1? Well, in that case, we're going to use our strategy of trial and error. Good morning, Ryan. So what I'd like us to do is look at one last problem for trial and error, and then we're going to get into what happens when we factor binomials. We're finally ready. Good morning, Claire. No worries. We're finally ready to look at, we started with four-term polynomials, went into trinomials, and we're ready for binomials. So let's check it out. We'll do that last problem together. Although this one you should have already done ahead of time. So let's compare our work together and see how it goes. So we have 6q squared minus 42pq minus 48p squared. The first thing we're going to do is we're going to look for a GCF, right? Remember that very first step, GCF. So notice here, I'm going to look at the numerical part of every term, and I recognize that I can definitely factor out a 6 from every single term. And then I'm going to look at the variable part. I have a q in my first term, I have a p and a q in my second term, and I have a p in my third term. So unfortunately, I cannot factor out any variable bases. Good morning, Doc. Good morning, Alyssa and Ria. So let's factor out a 6 from all three terms first. So essentially, we're just dividing out that 6. So we're left with q squared. Sorry, my q's look a little weird. Minus 7pq minus 8p squared. Perfect. Good morning, Johanna. So the next thing I'm going to do is I'm actually going to cover up that 6, right? Because that's my GCF, so I'm just holding on to it. I'm saying I don't want you to be distracting, so I'm just going to hold on to that. Next, I notice that I have a trinomial. My leading coefficient is a 1. It's a 1q squared minus 7pq minus 8p squared. So 1 is my A, negative 7 is B, negative 8 is C. So that means I'm going to use trial and error, right? Leading coefficient is equal to 1. It's a trinomial. So I have A times C, or 1 times negative 8, which gives me negative 8. And I want to find factors of negative 8 that combine to give me negative 7. So I have 1 times 8, 2 times 4. Notice that we want to get a negative 8, and we also want our factors to be combined to give us a negative 7, which means the larger number must carry the negative sign. So we start with 1 times a negative 8 is a negative 8. Yes. Good morning, Kevin. And then 1 minus 8 is negative 7. So right away, we have found our two factors. So we're ready to go ahead and write out our factored form. Remember, notice here that my power is 2, so I'm going to have 2 sets of parentheses, generally speaking, when I actually factor this. Notice my first term is q squared, and we have to think about breaking q down. So q squared breaks down evenly into q times q. That's definitely going to be the first position in each set of parentheses. Notice I have a positive 1 and a negative 8, so I'm going to go ahead and put those both in the parentheses, but keep in mind that my last term has p squared in it. So when I break down p squared, I'm going to break that down as p times p. So my factored form here initially is q plus 1p times q minus 8p, and we're going to bring the 6 right down in front. And that is my answer. I do want to do yet one more check for you as a reminder of how we go through this process. So I'm going to go ahead and write check here. We've got 6 times q plus 1p times q minus 8p. Remember that this is a refresher of Chapter 6. Chapter 6, we learned how to multiply binomials. So at this point, you should all be pros. You should all be masters at multiplying binomials. So we have q times q, which is q squared, q times a negative 8p, which is negative 8pq. 1p times q, which is positive 1pq, and then positive 1p times a negative 8p is a negative 8p squared. This whole thing is being multiplied by 6. We can combine like terms first and then distribute the 6. So we have q squared. Negative 8pq plus 1pq is negative 7pq, right? All we do when we combine like terms is we focus on their coefficients and we keep the variables exactly the same. Minus 8p squared. And of course, now let's distribute that 6, that coefficient. Distributing 6 gives us 6q squared minus 42pq minus 48p squared. And ta-da! Success. That is one of the beautiful pieces about factoring. You can factor the trinomial, binomial, four-term polynomial, whatever it is, and then you can check it. You can actually check it. You can literally say, if I distribute, do I get the original polynomial? And if you do, 9 times out of 10, you're golden. The only issue, nice, Kayla, that's awesome. The only issue you may come across is not factoring out the GCF. So when you distribute, you get the original, but it's not quite right because you didn't factor completely. So you just have to be super careful. That's why I say to you all, GCF first, okay? All right, so why don't we turn the page and take a look at our next strategy for factoring binomials. And what I'd actually like to do is, again, just briefly run through your flow chart so that you're a little bit more comfortable about where we are right now. So let's take a look at the flow chart together. So notice here, as always, is there a GCF? Is it a leading negative? You have to factor that out first, right? Then you say, how many terms are there? Okay, so after we determine, you know, how many terms there are, is it a binomial, is it a trinomial, is it a four-term polynomial? Right, exactly, Doc. At this point, we are now ready to explore what happens when we have a binomial, 2 terms. Now, I do want to comment that for Math 098, we're only going to learn one factoring formula, and that is the factoring the difference of 2 squares. When you go into your intermediate algebra course, your next course, Math 104, that's when you'll learn that there are actually 2 more formulas that you should know for factoring binomials, and that is the sum and difference of 2 cubes. So don't think that for binomials there's just a one and done formula. There's not. You are going to learn 2 more next semester whenever you resume your algebra courses, okay? But for now, difference of 2 squares, that's all we're going to cover. Okay, so I want to show you what that looks like, and I think you're really going to love it. I think you're going to say, oh my gosh, that's it? So check this out. So I'm going to put the flow chart away, and let's go to your notes for factoring binomials using the difference of 2 squares. Okay. The first thing I want you to notice is that I've given you here a list of perfect squares because I want you to understand what I mean by perfect squares. So 1 is a perfect square because 1 times 1 is 1. 4 is a perfect square because 2 times 2 is 4. 9 is a perfect square because 3 times 3 is 9. And the other things you'll notice is that you can take the square root of each of these numbers, right? Like for instance, if you took the square root of 49, you would get 7 because 7 times 7 is 49. So I want you to think about that. If you're ever faced with a value and you're not sure what it breaks down into, simply take the square root. So you can take the square root of a perfect square. Okay, if you take the square root of a perfect square, you'll get exactly what it was before it was squared. So for instance, let's do square root of 169. So if we take our calculators, we punch in second x squared, right? Because now we have square root, and we type in 169, we get 13. What this means is that 13 times 13 gives us 169. So we know that 169 is in fact a perfect square. Now, in terms of your variables, notice that in order to be a perfect square, you have to have an even power, right? Think about this as if you were to break down x squared, wouldn't you break it down as x times x? So that's a perfect square. If you had x to the fourth, wouldn't you break that down as x squared times x squared? Because x squared times x squared is x to the fourth. If you have x to the sixth, wouldn't you break that down as x to the third times x to the third? Because remember, x to the third times x to the third is x to the sixth. If that throws you off, remember the product rule. Keep the base, add the powers. Keep the base, add the powers. That's exactly what we're doing here. So as long as you have an even power for your variable, it is a perfect square. All right, on that note, I would like you to just observe this first example here. I have 16x squared minus 25. So the first thing I'm going to notice is that I do not have a GCF. I can't factor anything out, so step one is complete. The next thing I'm going to notice is that I have a binomial. So according to my flow chart, it says I should factor this as the difference of two squares. Now, is this the difference of two squares? Okay. Well, you have a minus sign here. Minus, subtraction, difference, right? This symbol means the difference between. Okay, so we definitely know it's the difference. That's the first check. Then, two perfect squares? Well, I don't know. Let's see. I have 16x squared. Well, with a 16x squared, I know 16 is a perfect square, right? Because 4 times 4 is 16. And I actually know x squared is a perfect square because x times x is x squared. And then I'm going to look at the 25. Well, 25 is definitely a perfect square also because 5 times 5 is 25. Okay, now that I've checked everything, I can safely say this is definitely the difference of two squares. And here's how we do this. This is going to be really cool. You'll see. This is going to be very, very awesome. So we're going to write out our two sets of parentheses, and we're just going to break down our binomial. So 16x squared is in our first term, right? And we learned that because it's a perfect square, we could break it down as such, meaning 4x times 4x gives us 16x squared. So in our first term, in each set of parentheses, we're going to write 4x. Next, notice I have a, excuse me, I'm so sorry. Notice I have a negative 25. Well, in order to break down a negative 25 into two factors, doesn't that have to be a positive 5 times a negative 5? Yes. A positive 5 times a negative 5 is a negative 25. So I'm going to write positive 5 and negative 5, and that is your factored form. Good morning, Ashanti. That's literally it. That's all you have to do for this one. Go ahead and write that down, and I want you to think about what it is that we did. We broke this down term by term, right? First set of terms, last set of terms. Also notice that in order to get a negative 25, we had to do a positive times a negative. There's no other way. Now, in case you don't believe me, I'm going to go ahead and write out the factored form, and I'm going to distribute just so I can prove to you that this is correct. We're going to distribute here. We have 4x times 4x is 16x squared. 4x times negative 5 is a negative 20x. 5 times 4x is 20x. And then 5 times a negative 5 is negative 25. Notice here, my negative 20x and a positive 20x, well, those are opposite terms. So they cancel each other out. And voila, 16x squared minus 25, and you're done. You have just solved this. Beautiful. Let's try moving through these together. So we start off with 9j squared minus 49. Okay, the first thing we notice is we do not have a GCF. So we're not going to factor that out because it doesn't exist. Okay. The next thing we have to say is this the difference of two squares? Well, let's start with writing difference because notice it's subtraction, so it's definitely the difference. And then, is it the difference of two squares? So let's check. Notice my first term is 9j squared. 9 is a perfect square, and so is j squared. So 9j squared, doesn't that break down into 3j times 3j? And then negative 49, well, 49 is definitely a perfect square because 7 times 7 is 49. Okay, so it is the difference of two squares. Let's go ahead and factor this. We discussed already that 9j squared breaks down into 3j times 3j. And then when you look at negative 49, you have to think, well, I need a positive and a negative, so it's a positive 7 times a negative 7. And that's it. You are done. Let's try it again. Number 2. X squared minus 81y squared. I want you to break this down piece by piece just like we did. And I'm actually only going to give you 60 seconds starting now. You are all fantastic. I love the fact that you broke this down very carefully. You noticed, okay, there's no GCF at first. This is definitely the difference of two perfect squares. So I'm going to write that here, difference of two squares. Thank you, Rachel. That's awesome. I noticed that in the chat. Perfect. So it's the difference of two squares. And then we say, okay, let's just factor it. X squared breaks down into x times x. And then negative 81y squared breaks down into plus 9y and minus 9y. And then you're done. That's literally it. Oh my God, that's fantastic. Check out number 3. 4m to the 6th power minus 169. Let's see what you got with this one. I love this. This is so great. You're all just throwing your answers so easily into the chat. That's fantastic. Kayla, that's amazing. I love that. Moada, Rachel, Noelia, Keith, or Doc, excuse me. Kayla, Claire, fantastic. This is beautiful work. This is beautiful work. There is no GCF at first, so remember we always check, right? But this is definitely the difference of two squares. So we break it up. 4m to the 6th breaks down into 2m to the 3rd times 2m to the 3rd. And then negative 169 breaks down into plus 13 and minus 13. Excellent work. Yeah, fantastic. That's just beautiful. All right, let's turn the page. Why don't you try number 4 then? Because you're all doing this incredibly well. So check out number 4. Negative 98h to the 2nd power plus 2k squared. Remember step number 1. Let's see what you got. I'm curious. Okay, so recall that your first step of factoring is always GCF. And notice from our flow chart that it says that if you have a leading negative, you have to factor that out as well. So notice here I have a negative 98h squared, so my leading term is definitely negative, so I'm going to want to factor out a negative with my GCF. If I look at the 98 and the 2, notice I can definitely factor out a 2 from both. So I'm going to start off by factoring out a negative 2. When I do so, I'm left with 49h squared minus k squared. Now that I have factored, you all were so close. Now that I have that negative 2 factored out, I'm going to cover it up, okay? I'm going to notice that I definitely have the difference, right? It's subtraction, the difference of two perfect squares. So I'm going to make a note of that. This is definitely the difference of two squares. And now what I want to do is factor it as such. So we're going to set up our sets of parentheses. Notice my first term is 49h squared, and that's going to break down into 7h and 7h. And then notice that for my second term, I have a negative k squared. So that can only be accomplished by taking a positive k and multiplying that by a negative k. Don't forget to bring down that negative 2 in front, and your final solution should be negative 2 times 7h plus k times 7h minus k. Excellent work, everyone. Excellent work. This one was definitely tricky, but you have to be careful. Take those baby steps, just one step at a time. GCF, and then factor using a factor formula if you possibly can. Check out number 5. What do you notice about number 5? So we have 36x squared plus 1. Go ahead and type into the chat what you notice. I don't want you to factor it. I just want you to talk to me, okay? I'm going to mute myself just for about 60 seconds so that we can have a conversation. Excellent. So throughout our conversations in the chat, we learned that yes, these are perfect squares, but the key here, and Ryan found it, is that it's not the difference between the two. I love that Kayla explored with, does this factor into possibly 6x plus 1 times 6x plus 1? Well, when she distributed, she noticed she did not get the original polynomial. So we're actually going to say that this is prime. What that means is that we're not going to be able to factor using real numbers. When you get into Math 104, you'll learn about something called the complex number system. You'll learn about imaginary numbers. And in the complex number system, yes, you could factor this, but you would have to use imaginary numbers to do so. So at this point right now, we're going to say that this is prime, cannot be factored using real numbers. Okay? It is not the difference of two squares. That's the sum of two squares, which we do not have a formula for. All right? And notice number 6. Number 6 is a squared minus b squared. The cool thing about this is I presented a squared minus b squared to you all because when you go ahead and factor it, right, this is the difference. These are definitely two squares. When you break this down, a squared becomes a times a, and then negative b squared becomes positive b times negative b. You have just found the general form for the difference of two squares. Whenever you factor the difference of two squares, it will always look like this form. Two sets of parentheses, one's a positive, one's a negative. Pretty cool, right? Okay. So I have an opportunity for you all to try to factor a challenge problem. I'm going to write out a binomial right below, and I would like you to factor the binomial completely, not partially, right? You don't just go part of the way. That doesn't make sense. That's never been the case. So I want to give you a few minutes to check this out. The first 3 people to input the correct answer into the chat will win a bonus test point. Are you ready? Okay, let's do it. We have 2m to the 4th minus 162. Go ahead and factor this binomial completely. First 3 to put in the chat wins a bonus point. Excellent work to the winners. Kayla, Mwala, and Claire. Very nice. Beautiful work. So the first thing we had to do was we had to factor out our GCF. And we noticed just by looking at this, we definitely can factor out a 2. So I'm going to do so. That leaves us with m to the 4th minus 81. Then I look at what's inside my set of parentheses and I say, okay, this is definitely the difference of two squares for sure, right? Notice that we have m to the 4th. That can be broken down into m squared times m squared. And then notice we have negative 81, which can definitely be broken down into minus 9 and then times positive 9. So bring that down. So far, so good. So 2 times m squared minus 9 times m squared plus 9. But wait a second. Look at what I have here. I have another difference of two squares. M squared minus 9. Can't this be broken down further? We have an m squared plus 9 that cannot be broken down, okay? So Rach, you are super, super close. You only wanted to factor what was in this set of parentheses, not the m squared plus 9. So m squared minus 9 breaks down into m times m gives us m squared. Negative 9 breaks down into minus 3 times a positive 3, right? That gives us m squared minus 9. And then all we have to do is bring down our other factors. And that is your final factored form. Now, the order of the sets of parentheses, again, they do not matter. You could write 2 times m squared plus 9 times m minus 3 times m plus 3, or 2 times m squared plus 9 times m plus 3 times m minus 3. Doesn't matter. It all means the same thing as long as you have your factors here. And notice that your power was m to the 4th. You have a m to the first, and another m to the second. So all together, do you see how that's a degree of 4, essentially? I know this is degree 1, degree 1, degree 2, but if we were to think about multiplying all of this, this would give us m to the 4th power, right? So I just want you to kind of play around with that idea. Notice we have our first factor of 2, our second factor, which is m minus 3, our third factor, which is m plus 3, and our fourth factor of m squared plus 9. It's very important to be able to identify the number of factors and their powers and all that good stuff. You did wonderful. That was a fantastic way to start week 13. Happy Monday, right? Seriously, that was really, really, really fantastic work. I'm expecting that when you go through this homework in Lumen and you're just trying this out on your own at home, it's going to go by super quick. You're going to be done with this in like seconds. So excellent work. I'm going to stop here because tomorrow's class, we're going to learn how to solve polynomial equations using factoring. So take this opportunity to really hone in on your factoring skills, and we're going to use them tomorrow in solving some equations. All right, everyone. Beautiful work today. Excellent work. I'll see you all tomorrow. Bye.